Welcome and thank you so much for joining me today. So we are going to be looking at application involving parabolas. Now, if you don't know what a parabola is, it links straight back to a quadratic. So I'm going to read this question and we're going to break it down to make it easy for you. A piece of wire measuring 100 centimeters in length is bent into a shape of a rectangle. Let x centimeters be the width of the rectangle. So to start off, I'm just going to draw a lovely picture of my rectangle. Now I know that with my rectangle, the perimeter is going to be 100 centimeters. 100 centimeters. Now I also know that x will be my width. So let's put this into words, because we need to say use the perimeter to write an expression for the length in terms of x. So we're trying to find what length is in relation to x and the perimeter. So if we're thinking about perimeter, we are just adding up all the sides. So that means we've got perimeter equals 2 width, so I was with 2w plus 2 length, because we've got 2 sides here. So that's our formula. Now all we need to do is substitute all of our information that we have. So I know that we have perimeter is 100. I know that we're using width as x. So I'm just going to go 100 equals 2x plus 2l. Now the next thing that I want to do, I'm going to factorise this and get 2 to be, because 2 is the common factor. So I'll take 2 out and then I'll have x plus l. Now, as we know with both of our sides, whatever you do to one side, you must do to the other side. So that means if I divide this side to get rid of 2, I divide the other side. So I would be dividing 100. So 100 divided by 2 equals 50. And I'm just left with x plus l on this side because I divided that side by 2. Now, the question asks us to write an expression for the length in terms of x. So we want to get l by itself. So I'm going to move x to the other side. Now, this is saying we've got 1x. How do I get 1x to 0? I have to take 1x or take x. So I take x on both sides. And that becomes length equals 50 minus x. Now, that is my expression for length in terms of x. So let's go to the next part. Write an equation for the area of a rectangle, a centimetre squared, in terms of x. So if we're thinking about area, what do we do for area? Let's go back to here. We do width times length. We're using x. So that means our length is actually 50 minus x. So if I write it, I'm just going to write my equation. 50 minus x, and it's being multiplied by x, which is the width. So that's my equation. I can expand it if I want to. X, which I will because I'll be using this later on. X is going to be times by x, negative x, and x is going to be times by 50. So that gives me negative x squared plus 50x. Okay, so I've got my equation here now, both of them. Decide on a suitable value for x. Well, at the moment, this is in our factorised form. If we want to think about the null rule, we can think about we need to get each side to equal 0, and that will give us our x values, because when y is equal to 0, it's going to show where it crosses the x-axis. So let's have a go. Well, straight away I can make x to be 0, and then 0 times 0 is 0, awesome. So I know one of my values for x is 0, and the other value is going to be when x is 50. 50 take 50 is 0. So that means 0 and 50. So what we are going to be looking at, because we're looking at area, it must be a positive values. So we are looking at when x is equal or greater than 0 and equal or less than 50. So those are the values that we are looking at. Now, but if we're thinking about area, we can't have we can't have one side being completely 50, one side being completely 0, because then it's not going to be. So when I'll take away e equal sign, and it has to be is greater than 0 and less than 50. Now let's look at this. Use a graph to determine the maximum area that can be formed. So the first thing I'm going to do in this space, I'm going to draw a lovely graph. With my graph, I know that I've got 50 here, 0 there. Now, one thing that you might not know, there's two ways that we can get this part. We can first put it into, we can square this and put it in turning point form, or another way that we can find the turning point is when you know that we've got 2 points that are crossing the x-axis, the turning point is going to be in the middle of both of them. So one way that we are able to do it is we are able to go, okay, well, if our parabola is going to be starting here and going here, I know that it is a negative parabola. So because of a is a negative, that means it's going to be a maximum. So I know it's going to go somewhere up here. I just don't know this point. The only thing I do know is that with a parabola, it's always going to be a halfway point. So what does that mean? Well, what's halfway between 0 and 50? X is 25. So I can sub x is 25 into this equation. So let's do that. So I'm just going to go y equals 25, 50 take 25. Okay. So 50 take 25 is 25, and we're doing 25 times 25. I'm just going to get my calculator out. Okay. "25 times 25 equals 625. So y equals 625. So that means here I have, when it's 25, it's 625. So we've found the maximum area that can be formed. Because if we think about this, we're using an equation where y will be the area, and this is our equation for area. So what will be the dimensions of the rectangle to achieve its maximum area? Well, if we can see here that our x is 25, we can see that the width is 25 plus 25, and that's 50. We've got 50 left over, so that means our dimensions is a square. 25 centimeters and 25 centimeters. So our length, our width are equal to get the biggest area. Really hope that helps you out in terms of application involving paraboles. There will be more videos to assist you. If you need any extra help, feel free to message me.